So what our philosophy is, okay, now this dynamic programming, as this diagram looks at, what it does is it divide the time interval into small planning periods, what we call as maybe 60 seconds or 80 seconds, etc., or maybe longer than this one. And that is divided into a number of small intervals, let's say every 2 seconds, every 4 seconds, etc. Now, so let's say this time is starting, then let's say for one of those, green is there. Okay. Now it has two decisions, whether the green to be terminated or whether the green to be extended. Now suppose the green is extended, then after 4 seconds, that is after the first interval, again there are two possibilities are there, whether the green to be terminated or whether the green to be extended. So like at each interval from every node, decision T can be traced actually for the entire planning period. Okay. Now all permutation combinations are there. Then find out what is an optimal path. Find out an optimal path, and that is to be adopted. Now this is also, there is a nice optimization principle is underlying there, and it achieves by dividing the entire time period into small planning periods, and then try to find out what is the optimal in that interval. What is good, only challenge is computation is more expensive, because is branching out into a number of things. If you want to apply for a number of functions, numerous combinations can come. Okay, now the other one is fuzzy is something that people use in many traffic applications, which can also be used into signal control. Okay, now for example, the fuzzy situation is deriving. Okay, now like, can we fully mathematically describe, okay, now this approach is fully congested? Okay. No, there is a fuzziness is there actually. Yeah, this is somewhat congested, this is highly congested, etc. So that subjectivity is brought into the help of fuzzy, and fuzzy rules can be made, and that can be used in the signal control. Okay, now another area that we need to think about now, one of the major challenges practically in our country is putting sensors on elevations. Okay. Cost of the sensor is not a big thing. Okay. Cost is coming down very significantly. Cost is not an issue of the sensor, but the cost of maintenance of that sensor is increasing and increasing. On one side, cost of the sensors are coming very cheap, but maintaining those things, that requires a camera, for example. That needs a lot of regular maintenance. It's not like surveillance camera. If it does not work for some time, no issue. Okay, no serious issue on common people. But a camera that is using for signal control, if it is covered with dust, predictions are gone. So that needs very high level of maintenance. Loops, for example, very cost effective. But putting the cables and cutting off all those cables, that needs very constant maintenance. So maintenance of these sensors have become a very nightmare. And one of the reasons why probably this is not picking up in many small cities, actually, because maintenance is very huge. So how can we do about that one? Look at non-conventional sensor. Okay, for example, Google, they give congestion levels are given by color coded. I'm not saying we should use only Google's, but this is one of the examples. Even Mappa India is also giving a similar data. So that becomes, the crowdsourced data becomes very popular. Now can that be used for signal control? Okay. Now very recently Delhi police really are asking whether this can be really implemented, because they're fed up with all these sensor maintenance, etc. So idea is very simple. We only need to know how the traffic is related to all the approaches. They have various color codes are there: green color, orange, red, and dark brown, indicating the levels of congestion that is coming from all the approaches. So once we get that one, then we can use these color codes and then say that okay, whether traffic, the green time has to be extended or terminated. Nice in concept, but there are some practical challenges are there. I'm not saying it is also a foolproof system. It has its own challenges. For example, For example, if there is a turning traffic is there, you want to give a separate green time for a turning traffic. This color code will not help because that color code is for the approach, not for through traffic and right hand traffic separately. So issues are there. Okay, so therefore now people are thinking about how can we fuse various sources of data. Okay. So even if you use crowdsourced data, it also has its own challenges actually, because suppose I am the learning agency, I do not own the data. Even if I use Google data, tomorrow Google can detect its own terms. Okay. Or even if some other apps is using, like TomTom or any other thing, they also can detect their own terms actually. So it has its own challenges. So one of the way forward is data fusion, that is using data from multiple sources so that the dependency on one particular sensor is minimized and it works on multiple sources of data. So now the challenge is, what is the challenge? The challenge is each type of sensors give data differently. For example, Loop gives a point data. Google Travel Time will give a spatial data, travel time data. How can we fuse these two different type of data? That is a challenge. Okay. Okay, I think the same slide in a different way. Okay. Which we can use AML, etc. in those situations. I'm not elaborating on that one. Now this is one example that we are trying to do. Okay, we look at two different type of sources of data. For example, Google Travel Time, and then let's say a surveillance camera or an aerial UAV which says the camera data from which the vehicle counts are there. So the idea here is, learn relationship between data by mining and analyzing the non-missing information. That means when data is coming from two different sensor sources without any interruption for a long time, then see whether there is a relationship can be established between these two different type of data, different sources of data. For example, the point data and as well as the spatial data. Even though there are two different type of data, whether there is a relationship can be established between these. So if you are able to establish a relationship between these two different type of data, which various AI tools can do that one, then when one sensor is missing, it can be this or it can be that, because this relationship is a two-way relationship. If one of the data is missed, the other can pitch in by editing that one. So at the end of the day, we may not be enslaved to one particular sensor, but there will be multiple sources of sensor will be there. And if we need one fails or even multiple fails, then you always will be redundancy. So this is something that is very actively happening on that. Okay, I think I've exceeded my 2 minutes. Thank you.